Hello everybody, this lesson is on an introduction to scientific notation. Usually when I start this lesson I always talk about the fact that at this point you probably have used a calculator, and if it's a scientific calculator sometimes you get numbers that are so big that you find this letter E with number next to it and you never know what it means. Now you're going to know what it means because it is scientific notation. Before we begin, I just want to go over the fact that you should know by now that there are numbers that are as big as like something like this, in the trillions, billions, quadrillions. Numbers like this exist, right, with a bunch of zeros, huge, huge, huge numbers. But also, numbers can be as small as this kind of decimal. And although we never actually see numbers like this usually in math, these numbers do exist. So I'm going to give you just a general definition of what scientific notation is. Scientific notation is used to abbreviate very large or very small numbers, okay, using a base 10, okay? In this case, a base 10 to an exponent that's either positive or negative. What does this mean? A long time ago, you might have learned about something that was called expanded or exponential form of a number. So if I gave you something like 700, the expanded form would be 7 times 10 to the power of 2. And in this case, the 10 to the power of 2 is because we have here 1, 2 zeros, and so our exponent is 2, or 2 decimal places. Scientific notation works on this principle where we would like our first number to be a number here that is between 1 and 9. And we kind of have like an imaginary decimal behind it, right? Because we can write it as like 7.0 times 10 to the power of 2. Okay, so that's basically what we are going to work on. But in this case, instead of something like 700, we're going to work on bigger numbers. Before we continue, let me give you just another example. If I were to give you the number 8,000 and I asked you to put this in expanded form, you would start with 8 times 10, and in this case it would be to the power of 3, right? Because we have 1, 2, 3 zeros or 3 decimal places after the 8. Okay, so now let's look at some examples of scientific notation. Instead of numbers that are in the thousands or the hundreds, I'm going to give you a bigger kind of number. Say something like this, 41,273. How would you change this number into scientific notation? Well, first, your goal is to put the decimal after the first number that is between 1 and 9. Over here, the first number that we see is 4. So I want to put the decimal right after this 4. My question to you is, where is the decimal right now in this number? Where is the decimal actually? You need to remember that there's always some kind of imaginary decimal here, kind of like when we're dealing with money, right? It's not just 41,273 done. Usually you add like a 00 to the end. Okay, so our goal right now is to get the decimal right after the 4. I want it to look something like this, 4.1273. That's the goal of scientific notation. So in this case, we also want to multiply it by a base 10 to the power of some number. Now, how do I figure out what that number exponent is on the 10? Well, I put that decimal here, right? Everybody sees that I put the decimal here. And it started off here. So I need to know, okay, how many times did I move my decimal over to get it after the 4? So in this case, I started here as a decimal. I started over here and I went 1, 2, 3, 4 decimal places. So in this case, it would be 4.1273 times 10 to the power of 4. And this is the number in scientific notation? I know this kind of looks strange to you. It's obviously the first time that you've seen it. So how about we take another number as an example. So say I were to give you something like a big number, like 4, say, billion, 900 million. Okay, that's a huge number. Now the goal for scientific notation is to move your decimal after the first number between 1 and 9. And in this case it's 4 again, so I want my decimal to essentially go here. Now if I do that, I say, okay, I have 4.9, and we don't care about the zeros. We have 4.9, and how many places did I move my decimal to get there? Well, my decimal started off here, so I went 1, 2, 3, 4, 5, 6, 7, 8, 9. I went 9 places to get to that 4.9 decimal place. So it's going to be 10 times 10 to the power of 9. Okay, so we are looking right now at big numbers, but we also deal with decimal numbers too. So here's an example. I would like you to try and write 0.0055 in scientific notation. Now remember, you want to get to the number that is, you want to have basically a number and then the decimal and then the rest of it. So if I want a number and then a decimal and then the rest of it for this question, you would have to put the decimal here. Okay, so in this case it would be 5.5. Now, instead of it being a big number, it's actually a really, really small decimal. So we're going to move the decimal not the way that we did it the last time, but actually we're going to be moving it this way. We're going to be moving it this way to get to 5.5. So in this case, we're going to actually have a negative exponent because we have a small number and we're making it into scientific notation. So how many decimal places did we move to get to the 5.5? Well, we moved it over 3 decimal places. But because it was a small number, and because we had to move the decimal place to the right, it's going to be a negative 3. So it's going to be 5.5 times 10 to the negative 3. Over here, I have 314.16, and I would like you to write this in scientific notation. Now remember, scientific notation is always a number, decimal, the rest of the numbers. So in this case, I want my decimal to go actually right here. And to do that, I have to move this decimal 2 places over to the left, which means I will have 3.1416 times 10. Now, what's the 10 going to be to the power of? Well, I moved it 2 decimal places, and it was a big number that I'm making little, so it's going to be a positive 2, or because I'm going to the right, I know that it's going to be a positive 2. Okay, so just some notes to keep in mind. Okay, when the original number, I'm going to say when the OG number is say greater than 1, like a giant number, decimal moves to the left. Right? We moved it this way. And exponent is positive. And in the other way, when the original number is less than 1, like a small decimal will then move to the right. And the exponent is the opposite, which is negative. And exponent is negative. So just 2 things to keep in mind when we have a big number and we are putting it in scientific notation. Now, another thing that we learn in this course is to change it from scientific to standard notation. So by doing this, we're kind of like going backwards, okay? So what if I gave you this example? What if I told you that the number was 4.4 times 10 to the power of 5? A few things that we need to remember. This 5 here tells me how many decimal places I have moved my decimal over to get it here. Another thing that I would like to point out is that the 5 is positive. Because the 5 is positive, that means it's going to be a big number. So we are going to move basically this decimal back to where it was before we put it in scientific notation. So to do that, we're actually going to have to work backwards and go this way with the decimal. And we are going to move it over 5 decimal places. So let me begin with my 4.4. And my decimal started off here. And now I'm going to have to move it 5 decimal places to the right. 1, 2, 3, 4, 5. So my decimal place will actually end here. And what do I put in these little curves here, you think? I'm actually just going to add zeros. So the number that we're actually looking at that started as 4.4 times 10 to the power of 5 is actually 444,000. So let's look at another example. In this case, let's look at a small number. So here is a number, we'll say 9.856 times 10 to the power of -3. So things that we need to look at are always our exponent. What is our exponent telling us? Our exponent is telling us how many decimal places we've moved to get here. And our exponent is also negative, which tells us that our original number must have been a very small number. So I'm not going to move the decimal places over this way because that makes it a huge number. I mean, 9,856 is a big number. I'm looking at a tiny decimal. So instead, I'm going to be moving my decimal over to the left side 3 times. So to do this, what I usually do is I just write out my number, my original number. I start where my decimal was originally, and I move it over 1, 2, 3 spots over here. I have 2 curves that are empty, so I'm just going to add zeros. And so in this case, our number originally was 0.00985 and 6. And that's how we go from scientific notation to regular standard notation. So in general, notes are usually given. I usually give notes in class where you have to convert from decimal to scientific or from scientific to decimal or number form. But in general, you're going to be moving over decimals left and right depending on what your exponent is for this case. Or you will be moving over the decimal either left or right depending on whether your number is big and small. Remember that when your number is small, your exponent is going to be negative. When your number is big, meaning greater than 1, your exponent is going to be positive. And don't be shy to use what I do and show how many times you're moving the decimal over. And that is it for your intro to scientific notation.